Hi and welcome back to Module 1, and we are looking at the properties and structure of matter. We're looking today at relative atomic mass. So as we have spoken about a couple of videos ago, looking at the periodic table, when we look at the periodic table, you will often notice that the atomic mass that is on the periodic table is not a whole number. Now, if we look at carbon-12, we have 6 protons and 6 neutrons, giving us a mass of 12. Why is it that we see 12.01 on the periodic table? And that, as you are probably aware due to our previous videos, is due to the presence of isotopes of each of these elements. So when we talk about chlorine, for example, chlorine is made up of 2 isotopes. There is chlorine-35 and chlorine-37. And again, 35 plus 37 divided by 2, if you think of normal averages, gives us 36. Well, then why is it that chlorine is actually 35.45 on our periodic table? That's because it's not quite as simple as that. We need to take into account their relative abundance of each of the isotopes. So looking here, chlorine-35 actually has a relative abundance of 75.8%. So 3/4 of the chlorine that we find is of chlorine-35 and only 24.2% of chlorine-37. So we call that its relative atomic abundance, and we use that to work out its relative atomic mass. So most mixtures or most elements are a mixture of different isotopes, and we can use that here. So there is a formula that we can use to determine this relative atomic mass. So we take the percentage of the first isotope. So in the case of chlorine, it was 75.8, and times it by the mass of isotope 1, which is 35. Then we add it to the percentage of isotope 2, which was 24.2. We're rounding it to 25 in this example, times 37, which is the mass of isotope 2. Press equals first, and then we divide it by 100, and we will get an abundance of about 35.3. And again, those numbers here are rounded on the periodic table. Or if we were using the correct relative abundance, you'd notice it was probably around that 35.45. So let's have a go at a couple together. So we have boron-10, which has a mass of 10.013 with a relative abundance of 19.91%, and boron-11, which has an atomic mass of 11.009, a relative abundance of 80.09. So what are we going to do here? You can stop the video and have a go yourself, and we can come back in a minute and work out if you are on the right track. So looking here, 19.91 divided by 100 times 10.013 plus 80.09 over 100 times 11.009, and we should get an answer of around 10.80. So have a go at this one, and we'll check our answers in class C then.